This is the notes for Chapter 5, Section 4 on simplifying algebraic fractions. These are also known as rational expressions, but we'll talk more about that later. So I just want you to remember for a second that when you have fractions, if you have two things that are multiplied together, as long as you have factors that are alike, you can cancel out those factors. So the a's will cancel just fine, and you simplify and get b over c. However, if you have sums or differences, a plus b over a plus c, those two a's here, these do not cancel out. And this is the number one thing that I get really angry about. But those a's are not factors. Those are actually terms, and terms can't cancel. Only factors can cancel. If you substitute in real numbers, you'll see why. So if we have 2 plus 5 over 2 plus 8, we get 7 over 10. Okay? That is definitely not the same as canceling out those 2's and getting 5 over 8. These two fractions are not equal to each other. Therefore, it helps prove that we can't cancel out those a's. So if you're going to write yourself a rule here, the first rule to write is you may only simplify factors. And remember, factors are things that are multiplied together. Terms are things that are added and subtracted. Okay, so let's start looking at the steps that we'll use in order to simplify these problems. So the first thing we're going to do is we're going to factor both the numerator and the denominator. Then we're going to cancel out any common factors. So the directions are pretty simple. The steps you take are pretty simple. It's just a matter of remembering how to factor. Alright, so here is our first example. My directions say simplify, and I have the problem 3x squared y z to the fourth over 7x squared y to the fifth z. Now, what we did before this was figure out how to simplify these expressions that are all factors. And that was pretty easy because we could use the exponent rules. But remember, we can also factor out a GCF and then simplify that. So if we take that first term and look for a GCF, our GCF in this case is going to be x squared y z, and when I factor that out of the top, I'm left with 3z cubed. In the denominator, when I factor out an x squared y z, I'm left with 7y to the fourth. So you'll notice that now I have factors that I can cancel. I have x squareds that cancel out, I have y's that cancel out, I have z's that cancel out, and all that's left are those things in the parentheses. So our final answer is 3z cubed over 7y to the fourth. Okay, that was the first example. Here is our second example. So this is example B. Directions again say simplify. And our problem is 3a plus 6 divided by 3a plus 3b. So the first thing I'm going to do is factor the numerator and the denominator. So in the numerator, I have a GCF of 3. So I factor out 3, and I'm left with a plus 2. In the denominator, I also have a GCF of 3. So I factor out 3, and I'm left with a plus b. Those 3's cancel out, and my final answer is a plus 2, a plus b. And this is it. Don't even think about canceling out those a's because they are not factors, they are terms. So I factored, and then my second step was to cancel any like factors, or cancel any fractions that equal 1, because 3 over 3 equals 1. Alright, here is another example. Again, the directions are going to say simplify. And our problem looks like this. X squared minus 9 over 2x plus 1, 3 plus x. So the first thing I need to do is I need to factor my numerator. And my numerator is going to factor into 2 binomials because I recognize x squared minus 9 is a dots. It's a difference of 2 squares. So I have x minus 3, x plus 3, and that's over 2x plus 1, 3 plus x. Now that I've factored, I can look at my different factors because each one of those parentheses is a factor. And as long as I cancel the whole parentheses, that parentheses matches something exactly on the bottom and the top, then I'm doing my math fine. Now, even though I just said they have to match exactly, what I mean is they mathematically have to match. So in this case, x plus 3 and 3 plus x are actually equivalent terms. So those cancel out, and my leftovers are my final answer. X minus 3 over 2x plus 1. So that's it. Alright, let's do one more example. (5a squared plus 4a minus 1 over 5a squared minus 10a minus 15. Now when you first look at that, because you're just learning it, you might think you could cancel out the 5a squareds. But remember, you can't. Those are terms. They are added or subtracted to the other terms that are in the numerator and the denominator. So you can't cancel those things out. But if you factor, you might find factors that are the same. So first we're going to take the numerator. It's a trinomial. The first term, the a value is greater than 1. So we either need to do our master product or we can guess and check in order to factor it. In this case, I know that my factors of 5 are only 5 and 1. Those are the only options. And then the factors of 1 are only 1 and 1. So now I just have to figure out which signs go where. It's a positive 4a, so I need 5a times plus 1, and then 5a minus 1. So there's our factored numerator. In the denominator, we can actually factor a GCF. So 5a squared minus 2a minus 3. Now it doesn't so much matter. I could have done master product factoring with that denominator, but this is just going to be easier. So remember, the 5 just comes along for the ride, and I need a factors of a are just a, and then factors of 3. So factors of 3 are going to be 3 and 1. And now we need to figure out which goes with which. So it's going to be a negative 3 and a positive 1. And therefore, when you subtract, you get negative 2. Alright, so now I look for my like factors. And I see that a plus 1 is the same as a plus 1. And it doesn't matter that they're not directly over each other. They still cancel out. And then I rewrite my final answer. I would have 5 a minus 1 in the numerator, 5 parentheses a minus 3 in the denominator. And you can just leave your answer like this. You do not need to multiply out the factors again. Just leave it like that. Okay, now you can go practice.